All right, so we are going to talk about elementary matrices and their effect on the determinant next. So take the identity matrix. If you perform a row operation, one of the three standard row operations to it, I'm going to say E1, I'm going to get E1 by multiplying the first row by 2 and adding that to the second row. So I'm going to perform that on the identity matrix. So I'm going to do, so this is obtained by multiplying row 1 times 2 and then adding it to row 2, and then I'm putting that into row 2. Okay. Or we can just cross that. That's pretty self-explanatory. So what we're going to do is we're going to do just this to the identity matrix. So 2 times 1 is 2 plus 0 is 2. That's 1, 0. 0, 0, 1. Okay, so this is called an elementary matrix because it's obtained from the identity by performing one elementary row operation. Okay, so now what I would like to do next is I would like to talk about the determinant of E1. So we know that the determinant of the identity matrix is equal to 1, and you can compute it if you don't believe me. But let's compute the determinant of this elementary matrix and see how it relates to the determinant of the identity. That would explain, that would tell us what row operations do to the determinant, what effects row operations have on the determinant. So, best thing to do here is a cofactor expansion along the first row because we have 2 zeros. So then we're going to say this is 1 times 1, 0, 0, 1, plus 0, plus 0. Well, the determinant of this is 1, so the determinant of that elementary matrix is the same as the determinant of the identity. So, by this evidence, it seems that this type of row operation has no effect on the determinant. On the determinant. Okay, let's do another row operation. Let's switch 2 rows. So I'm going to get E2 by, so this E2 is going to be obtained by switching row 1 and row 2. So let's see, that means 0, 1, 0, 1, 0, 0, 0, 0, 1. All right. So next I want to compute the determinant of this matrix, just checking to make sure you can see. We want to compute the determinant of this matrix and see what effect that's going to have, this operation has on the determinant. So the determinant of E2 is going to be, I'm going to do a cofactor expansion along the first column. And so you get 0 plus 1 times negative 1 to the power, let's see, first column, second rows. So that's 2 plus 1 times the resulting minor, which is 1, 0, 0, 1. Okay, the determinant of this is 1, this is a negative 1, so the determinant of that is negative 1. So it seems like switching 2 rows has the effect of multiplying the determinant by a factor of negative 1. So multiply the determinant by -1. I need to move the camera that way for the third row operation. So next I'm going to come up with an E3, which is, I'm going to obtain E3 by multiplying row 2 by 5. Okay, so I'm going to take the identity matrix and I'm going to multiply the second row by 5. So that's going to yield this matrix here. And the determinant of E3 is going to be, let's see, well, I can do a cofactor expansion along the first row. So that's 1 times the minor 5001, which equals to 1 times 5, which is 5. Okay, so it seems that multiplying a row by a number has the effect of multiplying the determinant by 5.